Internal combustion is the great source of power which has made possible the transportation system we have today. And here are the boys who provide the power that drives your car. Our old friends, air, fuel, and...
Hey, Sparky, come on out.
ignition.
Hey, fellas, look here.
What kind of an engine is that?
I don't know. You got me.
That's a big diesel engine, boys.
What?
A diesel engine. It's an internal combustion engine, but it works differently than a gasoline engine.
Can we make it go?
Of course you can make it go. In fact, it won't go without you. Why don't you look it over?
What are we waiting for? Come on, fellas. Let's go.
Yes, air, fuel, and ignition cooperate to give the diesel its power, but they get together in somewhat different ways than in an automobile engine.
No carburetor?
Yeah. No carburetor, no battery, no coil, no spark plug. What an engine.
Yes, that's right, boys. No carburetor, no coil or wiring, no spark plugs. But in a diesel engine, you get along without them. And we're going to find out why and how. Remember, in the gasoline engine, air and fuel are combined in the carburetor to form an explosive mixture. Fuel enters the carburetor at the float chamber. Air is sucked in through an air cleaner, then pulled past a tiny opening called the fuel jet, which mixes fuel in the proper proportion to air. This explosive mist is fed into the cylinder on the intake stroke of the piston, then compressed on the compression stroke. Meanwhile, our third member of the internal combustion trio is waiting in the ignition system in the form of electrical energy. At the proper time, the distributor sends him on his way to the cylinder where the explosive mixture has been compressed and bam, the explosion that provides the power stroke. Then the piston comes up on the exhaust stroke to push the burned gases out of the cylinder. And so we have the four-stroke power cycle of the gasoline engine which drives your car. Intake, compression, power, exhaust. The basic parts of a diesel engine are the same as those of a gasoline engine. There are cylinders, pistons, connecting rods, and a crankshaft. The valve mechanism is essentially the same as in a gasoline engine. There is also a cooling system to get rid of the heat caused by combustion. This is a 3-cylinder inline engine, but various arrangements of the cylinders are practical. V-type, pancake, and so on. In a diesel engine, there is no carburetor to mix air and fuel outside the cylinder, and no electrical system to provide ignition in the form of high-voltage electricity. But ignition doesn't have to be electrical. Ignition is simply heat. Heat enough to set fire to something. If you squeeze any substance hard enough, compress it, it gets hot. Even our friend air can be compressed to a very high temperature, high enough to ignite fuel if it is present. Lucky thing fuel wasn't along, or there would have been an explosion. In this principle of compression ignition lies the major difference between gasoline and diesel engines. A compression ratio of about 8-to-1 is common in automobile engines today. On the compression stroke, the piston squeezes the air-fuel mixture in the chamber to 1/8 of its former volume. The diesel is a higher compression engine. At the top of a diesel compression stroke, the air in the cylinder may be squeezed to as little as 1/20th of the former volume. And when you squeeze air that hard, it gets hot, 1,000 degrees Fahrenheit or higher. Because of higher compression, and therefore higher temperatures in the cylinders, diesel engines can use fuels which are less volatile than gasoline. Higher compression and the resulting higher pressures require a diesel engine to be made stronger than a gasoline engine. And because of the higher compression, fuel and air cannot be mixed outside the cylinder in a carburetor. The mixture would start burning too soon. The air has to be compressed alone, and the fuel put into the cylinder just when we want it to start burning. In place of the carburetor, we have a fuel injection system to get the fuel into the combustion chamber. Because we don't need a spark plug, we can put the fuel nozzle in its place at the top of the cylinder, connected to a high pressure pump to force in the fuel. Now we have all the basic parts necessary for a diesel engine. To make it go, we need only air, fuel, and ignition. And here comes the first one, air. Whoops, the valve closes and there's no way out. Notice that at the end of diesel's intake stroke, the cylinder is filled with air, all air, not an air-fuel mixture.
What is this? Another squeeze play?
Exactly, my friend. You're going to work in a diesel engine, then the compression stroke, and his temperature rises steadily until it's hot enough to start fuel burning. Now, if fuel were only here.
Hey, what's up?
Your pals are waiting for you. This will do it. Fuel is pumped to the nozzle and sprayed into the chamber through tiny holes where the heated air ignites it immediately. The power stroke is completed and the exhaust valve opens as the piston returns on the exhaust stroke, driving the burned gases out of the cylinder. That completes the diesel's 4-stroke cycle. Intake, compression, power, exhaust. The power comes from the expansion of the burning gases, just as in a gasoline engine. But in a diesel, they expand more because of the higher compression and greater heat. That's one reason for the diesel's high efficiency. From the very beginning of the diesel, just before 1900, size and weight were a great disadvantage. Because diesels were so efficient and economical, engineers have constantly worked to cut down the ratio of weight to horsepower and make them more useful and versatile engines. This work has eventually resulted in making the diesel engine light enough to use in heavy-duty vehicles. The adoption of the automotive-type electric self-starter also contributed to its wider usefulness. While researchmen were improving and refining basic diesel engine designs, they also developed a two-cycle diesel engine. Instead of having the engine itself draw in fresh air and expel the burned gases, two-cycle diesel engines have a special fan or air pump to do the job. In many two-cycle engines, the intake valve is eliminated and replaced with a row of holes or intake ports in the cylinder wall. Then, to force large quantities of air into the cylinder quickly, a blower is added on the outside. This is sort of a fan or air pump. The blower most commonly used today is the Roots-type blower. It works somewhat like a pair of revolving doors. Of course, with the ordinary revolving doors, anyone can come in and just as easily get out. But if we move the two doors together so they interlock, then drive one clockwise, the other counterclockwise, we have the principle of the Roots-type blower. This unit provides a continuous supply of fresh air for combustion and a means of blowing exhaust gases out whenever the valve is open. The blower itself is a casing with two rotors, each having lobes which fit together somewhat like gear teeth. They give a constant flow of fresh air. This supply of air makes possible the two-stroke cycle, commonly called the two-cycle diesel engine. As the piston starts up, it seals off the ports and goes on to compress and heat the air to a high temperature. At the top of the stroke, fuel is injected, and the expansion of burning gases drives the piston down on the power stroke. As the piston is driven down, the exhaust valve opens. The ports are uncovered, and the blower forces air in, driving out the burned gases and filling the cylinder with fresh air. 2 or even 4 exhaust valves may be used in removing gases. And that's the complete cycle. Compression, power. Compression, power. In a two-cycle diesel, every downstroke is a power stroke. The heart of every diesel is the fuel injection system. All diesels have a nozzle in each cylinder through which fuel is sprayed into the hot compressed air. In some engines, the high-pressure pump and nozzle are combined into individual units, one for each cylinder. Other engines have a central pressure pump that supplies fuel to all cylinders. In principle, the injector spray nozzle is like a squirt gun.
But how does it work?
Fill it up, little fellow, and we'll find out. When we apply pressure, fuel squirts out the holes in the bottom.
Simple, isn't it?
Yes, it's simple enough in principle, but these fuel injectors are precise mechanisms that accurately measure the fuel and force it into the cylinder at exactly the right time. The jets through which the fuel must be forced have a diameter as small as 5/1000ths of an inch, less than the size of a human hair. A control changes the amount of fuel injected into the cylinder as the throttle is opened or closed. As the piston approaches the top of the compression stroke, a tiny drop of oil is injected into the combustion chamber under pressures as high as 20,000 pounds per square inch. Since the beginning of the diesel engine, changes in design plus improvements in materials have brought the weight of the modern diesel down to as low as 6 pounds per horsepower.
We sure made those diesel engines go. Hey, fellas, we're the power trio. That's us.
Why, in one of those engines we could drive a... Say, mister, what do we drive with diesel engines?
A great many things, boys. The productivity, economy, and reliability of the modern diesel engine make it particularly useful wherever there is tough work to be done. On any job, big or small, you'll find dependable, efficient diesel power. For instance, diesel power builds and maintains our modern highways and powers the trucks and buses that use them. Diesel power builds dams and irrigation canals, operates oil fields, and mines raw materials. Diesel power propels tugboats and towboats, fishing and pleasure craft, and all sizes of military vehicles and craft. This modern, reliable power plant becomes more versatile every day, driving farm tractors and machinery, pulling the fast freight and streamlined passenger trains. Diesel power is also used to safeguard our hospitals, communication centers, and factories during emergencies. And to provide precise electric power for missile guidance and outer defense lines. Yes, even the Carnival carries its own diesel power units.